Yep. Marlowe Playground.
Great, great. And if I open up, we'll just actually let's do it now. So if I just before we're already recording, but let's just get this preparation done so that we don't have to mess around with that during the lesson. So if we start a new project, say, because I want to have a one Haskell one, so you can see the Haskell one now, yeah.
Yep.
Cool. And I want to also have open another tab. So can you see my second tab here? Oh, it's still loading.
Yep.
Yep. But you can see my second tab, yeah?
Yeah, we can see it loading.
Okay.
So you can run two. Are you running the same project or different projects in these tabs?
I was gonna be running different projects because it's changed a little bit in terms of that. It's not as easy to just flick between them. So I'm gonna run one Blockly one and one Haskell one, basically to so like we've done before, we'll design the contract in Blockly, and then we'll design it in Blockly, and then we'll move it to Haskell to generalize the number of people that can be in it, and also to like work around some of the issues that we bump into like immediately. So let's start with Blockly. So what we're trying to do is crowdfunding, which means we have something to give away, in which case those are going to be Ada Makerspace tokens, or actually we think it matters tokens. And basically we want participants to fund our project. So they deposit money into our account and they'll get our tokens in proportion to their funding amount, essentially.
Yep.
So
you would receive a certain amount of tokens per ADA set by the contract.
Yeah. Oh yeah. So that's that's quite a good way of doing it. So I mean, I was initially trying to divide the tokens that are divide the
pot like evenly in a way.
Divide the pot in proportion to how much was paid, which is slightly different to a fixed price per ADA per token.
It'd be interesting to look at how those are kind of different. Go with what you were doing, since you got it kind of warped out, but then we can also talk about how you might change it for those other use cases.
Yeah, perfect. Because I think I mean, the reason I'm talking about the specific one is because I actually ran into some limitations, and let's just start, and I'll tell you which, as the limitations come in, what can actually happen. So okay, so first of all, the pool, I'm going to call it the pool. They need to put some tokens in. That's the first step. So we can have a when there's a deposit by, and look, one thing that's new is when you've got something selected, then the slots that can be filled in kind of come up here. So we can go.
Oh, that's very helpful.
Yeah. So that we can say pool. Don't know if pool is the right term, but that's what I've been using. And then again, the next thing is value. So we've got and here's the first kind of we've got a choice here. So we can just put in a fixed number, or we can potentially use a parameter to this contract, which makes it configurable, which sounds nice. So let's do that. So we can have, I don't know, total, we think it matters. Cool. And then the currency. can be, we're just going to use token name. We think it matters. So this is going to be our token that we mint. But yeah, I'm assuming we're bringing it into the contract.
Yep.
And for now, this is just going to take a party. So for now, they can just deposit it into their own account. The pool, depositing into the pool account, that makes sense. Cool. So that's the pool ready. Now, and we'll do slot 10. I don't know, we'll give everybody 10 slots. Yeah, actually, just for simplicity, and we can try and bring this parameter back shortly, but I am just going to put in a constant value here. So I'm going to say 1,000 tokens coming into this contract. Again, we would like this to be variable, and we could potentially use the parameter, but we'll see after the fact why it gets a little bit difficult. Anyway, and now we want the next person to deposit, right? So when there's another deposit by user 0, and they can deposit an amount. Now, here's where I kind of, so the token's going to be ADA. They're going to deposit some ADA. But like the amount is something that we really want them to choose, right?
Mm-hmm.
So I was looking at these, kind of hoping that it was going to be one of these that they can deposit. So, you know, there's a constant, which I ultimately ended up being with, and I deferred that choice to Haskell, but it's kind of not ideal. So another option could be, well, we could have a choice, right? Like we could have the user make a choice first. So, you know, choice deposit by user 0. So yeah, potentially that's something we can do. So we can have them make a choice first, and then have them do a deposit, which is the amount that they chose.
So in the simulator, if you were to run this, the contract's going to offer them a opportunity to just enter any amount.
Yeah. So let's do that. So when so we've already got a when. So it's an action, which is a choice. So the choice name is deposit. And the choice owner is user 0. So yeah, you can duplicate these names across multiple users, because when you're looking up a value, it has both a name and a role. So that's fine.
Gotcha.
And then the choice bounds can be, so this is like the upper and lower limit of the user making the choice. So let's say, I don't know. The first question we have to do, let's deal with actual ADA rather than Lovelace. So we'll have millions. So between 1 million Lovelace, which is 1 ADA, and like, I don't know, I will make the numbers still quite small. So 10 million. So, you know, they can kind of contribute anywhere between 1 ADA and 10 ADA in this case. And again, this should be done by slot 20, I guess. And now once they've done the deposit, then they should, once they've chosen how much they're going to deposit, then they should actually deposit.
Gotcha.
So yeah, it's a little bit strange. It'd be nice if there was a way of just saying whatever they deposit, just take that as a given. Don't make them make a choice. The deposit is the choice. But looking at these value options, there's just nothing we can choose, right? I did initially try to have look at this use name, because that looked promising, like maybe it was going to assign the amount they deposited to a variable, but that's not how it works. This is a reference to some name that's already been defined. So it's
gotcha.
Yeah, it's not going to help. Anyway, that works. And now, so they should deposit it into the pool directly. I mean, you could have this extra step of depositing into their own account and then paying into the pool, but there's no benefit to that here.
Yeah, no benefit.
Okay, and at that point, what we want to do is, well, basically have the pool pay them the we think it matters. So we can do that. Payee is different. So it's from the pool to the party, which is user 0. And the amount is going to be.
Let's just make it a 1-to-1 ratio for
for now, because that's super easy, right?
Yes,
so
I understand.
We can duplicate that, but I will extrapolate on this like really quickly, because there's going to be an issue, which you'll see.
Well, what I was meaning too by that was that on that between choice, if they chose 1 ADA, they're going to get 1 WTIM back.
Yeah.
If they choose 10 ADA, they're going to get 10.
Yeah. Okay. Yeah. Perfect. Yeah. So let's just get this thing running, and then I'll show you why we're going to have problems with the other thing.
Gotcha.
Yeah. So let's just and then let's just fill these things in, and here we're waiting for a deposit. So up to slot 30, close. Close. Everything is connected, I think. Yeah, that's one technique that actually, if you accidentally haven't connected something, shaking it around like this, like if something's not connected, say this wasn't connected.
Oh, it would leave. Gotcha.
You kind of see it hanging behind. So it's this is my patented tree shaking method.
It's a good idea. It makes sense.
Yeah, just because I've had a few disconnected ones. I mean, it kind of clicks in pretty good, but okay, so we send it to simulator. We start the simulation. The pool deposits 1,000. And then we've got a choice here between one.
Do 3 million.
3 million.
Yeah.
Cool. Okay, and then they've got the option of actually depositing, which they do. And what's happened? Well, right now, because it's very simple, so they've paid 3, and the pool got 3, and the user 0 got all of the units. So that's like, yeah, it's all right. But
it's working, but we're not,
yeah.
it's not really acting as a crowdfunding mechanism.
No.
It's acting as this is you want to be the first investor.
Yeah. It's a sale, right? It's basically a sale with whatever price you want. Anyway, so the real thing, what you want to do is there's this division operator, right? Which lets you pay a ratio of something.
Gotcha.
So for example, if we wanted to make the ratio a half, then you do a 1/2. The problem is that what we actually want, right, is we want this denominator to be the 10 million. And we want this numerator to be the actual deposit. Like,
yeah, I gotcha.
This thing here. Except you can't do that. I want to slot this into here.
Yeah, I see what you're saying.
And it's not it's not just a Blockly issue. Like, it's not something that we can really, even in the Haskell types, you can't do that. You can't make this this kind of thing variable.
So you really would be more limited to not really allowing a choice bounds on the amount they invested. You'd have to maybe in this type of contract, you'd have to have a pool say that the minimum you can attribute is whatever 1/10 of the pool is or something.
Yeah, something along those lines. So it's quite annoying. And that's the kind of limitation I ran into doing this. So you can kind of fake it like the way we faked it before by generating this contract from Haskell, and then in Haskell it's variable, but then it's not, what we're doing is changing something. Like, we're really moving a choice that happens during the contract to a choice that happens before the contract. And maybe that's okay. And that's the path that I took when preparing for this. But one thing we could potentially try is actually the other option, which is simply we pay according to, we pay one, I don't know, you have a fixed ADA price per
token. So if you wanted to crowdfund and offer 100 tokens per ADA, you could do it that way.
Yeah. So I think we can do that. So let's just change our requirements to something we can do, which is always great. So instead, basically, instead of dividing the total amount that we have by the proportion of the deposit that was made, what we can do is we can just have the pool start out with a huge amount that's never going to be all exhausted, and then we can have a price per, and like, why don't we just say, for simplicity's sake, the price should be 1 token per ADA.
That's fine.
Yeah, so one token per ADA, not per Lovelace, right? So that means that we're going to pay that becomes now let's just to make it interesting, let's make it 2 tokens per ADA, okay?
Yeah, that sounds good.
Yeah. So what we're going to have is that choice. That's going to be what we're multiplying by. And So it's going to be, remember that the deposit is in Lovelace. So we're going to do 2 divided by 1 million. There to pay to users. So that means that if I'm correct, that should pay, if you pay 2 ADA, that should pay you 2 tokens. Sorry, if you pay 1 ADA, that should pay you 2 tokens. So that's like, we're dividing this amount that they paid by 1 million to convert it from Lovelace to ADA. And then we're multiplying it by 2, which is how many tokens they're getting per ADA.
Gotcha. So if you ran this in the simulator now and chose that same 3 million deposit, 6, we should get so 6 WTIM.
Correct. Yeah. So let's do 3. Okay. So, oh yeah, sorry, and we've got a deposit. Yeah, so
boom.
Yeah, so that works, and that's great actually, because I plan to spend this whole session moaning about the limitations, but if we do it like this, then that works.
And I think it makes a lot of sense on the choice bounds too. So in a crowdfunding campaign, you want to be able to, like, I think you would definitely use, maybe like 10 ADA and 1,000 ADA, as like realistic, things, but it does give you like an ability to create a low enough entry area for just about anyone to be able to take part in the crowdfunding campaign, but it also creates a cutoff point. So you can't have like someone with a ton of ADA just buy the whole, you can only come in at, the most you can contribute is a certain amount.
Yeah. Cool. Okay. So I've just increased those numbers slightly. Let's simulate it just to make sure. So the pool just puts in a whole lot of money. Like the idea here is really that the pool has more tokens than.
But I think that you would also want to set like realistically for this, in like a IDO type of use case, you usually only do like 10% of what your total supply is or something.
Yes.
So I think that would be the way in this crowdfunding contract that you could determine the amount that you were making available in this crowdfunding. So so you could realistically even, like, could be a very small crowdfunding campaign that you only offered 1,000 tokens in, and when it is like something very limited.
Okay, so let's try and probably at the end of this lesson, because I think like there's a lot of depth to just this part. So what I really want to do is really kind of think about those edge cases of what if there's a small amount of tokens, and what happens if we actually aren't able to, because we've only got to allow as many contributions. Like we can't take any more contributions once we've run out of tokens, basically.
Yep, exactly.
So yeah, I don't know. We've made these a bit bigger, so now you can do 100 ADA. This is always a little bit misleading because it says units of ADA, but it's really talking about
Lovelace.
Lovelace, yeah. So
there you go. You got 200 units of WTIM.
Yeah, cool.
That's awesome.
Okay. So before we, yeah, so a few, I guess, yeah, a few things we have to do. Let's put in a second user, and one tool that I've used. Let me just save this. Something like that. One useful thing that I've kind of started doing is I've separated a different step. Like when I'm working on these, instead of keeping it all connected all the time, I kind of pull it out, right? So that's, no, that's, I've done it wrong.
Helps you kind of break up the stages
yeah.
of the
So
contract.
this is like the pool depositing, and then this whole thing is the user depositing, right?
Yeah,
and I think I can duplicate this whole thing, right, for the second user.
and it kind of helps, because the things get so long.
Yeah,
to look at it in the wide screen, it makes it a little bit easier too.
yeah, definitely. The only thing is, obviously, before you do anything, like, you have to connect it back up.
Yeah, put it back together.
Yeah. But there's actually further splitting that we can do. And this is where I zoom out a bit. And can you still read the?
It's just right. Yeah, it's right on the edge of
legibility.
Yeah. That's as small as you can go.
Yeah, cool. Okay. Because what I'll do is actually move this pay down here as well. And there's a reason being for that. So if you think about it, what we actually want it to do is, user 0 deposits, then user 1 deposits, then we pay user 1, and then pay user 0. Something like that. I usually like to kind of do a inside out thing, and that's because it just kind of makes the code a little bit easier. So the last user, I mean, it doesn't matter. The order of payments don't actually matter. It's the final state that matters. But last in, first out. So that means, like, if user 1 deposits last, then they get paid first. And there's a kind of reason for that, which you'll see later.
And why do you
it's just kind of easier, because then we can kind of
you leave off, you can kind of leave off from where that's ending and start
again. I guess
again.
like in a way, like, the way I think about this is that, I've got a stack of debts, right? So every time I get a deposit, I owe someone something, right? And that's stacking up. So imagine, like, I'm stacking IOUs and a stack of papers, right? And then when I'm paying them off, I'm taking them from the top and paying them off one by one. That's kind of how I think about it. And again, it's not that important, really. But yeah, just yeah, so just this is we're going to be in here, that's going to go in there, so we kind of come in here, then this is going to go there, then this is going to go here, and then this is going to go here.
Yeah.
Now there's a little bit of a something we can do kind of immediately, is make a decision of whether we even want any more contributors. Like, have we reached our maximum? So you know what I mean? Like,
yep. What's the trigger event for ending the campaign?
Yeah, that's right. So at this stage, we don't want any more participants that don't get to play anymore.
That's for the purpose of kind of how a lot of crowdfunding campaigns work. If it's possible, we could go off of the deposit amount, make it like a little bit smaller, and then each one of these parties could deposit, like one could deposit 30% of what's needed, one could
Yeah.
deposit,
Yeah.
70%, and then that would equal, the pool, the existing pool's gone.
Yeah. So actually, we've done these things in the millions here, but I'm gonna backtrack and I'm just gonna make them more manageable numbers for the sake of the lesson. So let's pretend our Lovelace is actually ADA now,
Yeah.
if that's okay.
Yeah.
So we'll go between 1 and 1,000 ADA, between 1 and 1,000. And we'll make this
just 1,000.
Okay, so we've got to be a little bit careful though, because if that's 1,000 and we're paying 2 per, we're paying 2 per ADA, then
oh yeah, you're right. So
let's make it 2,000.
2,000. You're correct. I'm sorry, I forgot about the.
Otherwise, we're going to end up in a situation immediately, which
yeah.
Cool. So, so basically, that changes things, I guess, a little bit, because what we want to do, I guess, is immediately when they deposit, when user 0 deposits, we'll pay them immediately. Because we have to look at our remaining balance and.
Oh, I got you. If that changes what you're going to do too much, we can. We don't have to do it.
No. It's fine. We've changed it enough that we're winging it at this point, so it's fine. I think this is the better approach than what I had before. So I think this is actually. I think thinking about this, like, rather than trying to rush into the Haskell code and go far, like get to the technical stuff, I really want to like think about the details of the contract and get it right. So this is perfect. This is
cool beans.
This basically came out as a result of our discussion, which is the kind of thing you're going to have when you're designing these contracts. Yeah, so they deposit and we pay them their WTIM tokens. Then what we really want to, so we're going to have a few issues again, but at this point, what we really want to do is decide. So we're going to put in an observation. I'm just going to move this other user later because we're not ready for them yet, but we can move this here. So same thing, like user deposits, they get paid. But now what we really want is once the first user has paid, I'll put the second user underneath because that's just a continuation of so we can have as many as we want of those. So the observations are, well, what we really want to do is if the value is greater than, so if some value is greater than some other value, and the value that we're going to be looking at is available currency of, so that takes a token, which will from the account of the pool.
Gotcha. That makes a lot of sense.
So we're saying basically, does the pool have any more tokens to give out? And I'm gonna leave a big gaping hole for a bug here, but it's okay, just for now. So I will say it is greater than 0. The hole for the bug is really that if we're greater than 0, like
everything is
no, like when we run out of deposit, then like we're going to be on 0.
Gotcha. Okay, yeah, gotcha.
Yeah. The problem is that the the problem is that we don't know how much the user is going to request. So really our available currency should be greater than the maximum, like it should be greater than the maximum amount that the person could buy, right?
Yeah.
Like, but let's just do 0 for now and then we'll fix it, because cool. So if there's more available, then we do that part, else we're done. So we just do a close contract. So otherwise, and then just at the end of user 2, we'll close. We're going to have to increase these slot numbers a little bit. So 40, 60. So that's going to go there. That's like the next user. And then that's going to go there. And then that's going to go there. It's a little bit annoying because you have to kind of put it together before you run it. And then you have to split it out again. I wish we could draw lines or something, but that's okay. So sending to simulator, we'll start the simulation. So we're depositing 2000 WTIM. And this time, let's have this user put in 500. So we're going to test the 2 cases, basically, where we stay, one where we stay under the limit and one where we go up to the limit. So there. And then user 0 is going to put in 500. And yeah, so what we've done so far is this part, I guess. We haven't paid out anything yet. And then user 2, actually, I would have expected to pay now. We'll see what happens.
Yeah, I know but that's actually the better use case. So, you know, because in a crowdfunding campaign, they shouldn't be paid out unless the campaign like hit a minimum threshold too.
Oh,
you know? So
yeah,
that's actually, I'm glad to see it. Then, you know, it's still waiting for something to happen before.
Yeah, we'll get to that. I think that's going to be a little bit of a complication, but let's just build it up slowly. So let's do another 50. So contract deposited, user did 500, participant.
We got our payouts, something messed up.
Yeah, something's messed up. So let's have a look. I'll just split it all up again. So user 0, and then we go pay user 0. And then we've got a user 1. Actually, if we keep going, user 1. Okay. So it should be paying. Let's just try and just get it back to the point where it worked. See what the problem is. So yeah, user 0 deposits, and we pay them. Oh, that's why. We've changed from 1 million to 1 per Lovelace, remember? So that, yeah, we changed everything to Ada instead of Lovelace, but here we didn't. So,
but I wonder why that was affecting why it was paying out the pool instead of the user still. Let's try it again. Let's run it again.
Yeah, let's jam it together and see. I'm pretty sure that was the issue, and I think we may have been misreading it, but I'm not quite sure. Let's have a look at it more carefully. So Center simulator. So start simulation. So this time, yeah, user one can deposit like 5. And okay.
And the user got paid this time, so that's good.
But after 5, we should have had a choice to it should have been user 2's turn. So let's have a look at what happened here. So if the pool has more than 0 tokens, then we do that part. Otherwise, we close. I mean, that looks pretty good to me. And the token is the same. Yeah. Because we paid 2, right? Okay. Let's do one thing. Let's just copy this, duplicate this. There's no reason why we can't have this if on the first user as well, like that. I mean, we know it's going to be the case, but it kind of makes them consistent, which is also good. So I'm just going to duplicate it here and just do a close here for now. And start. Okay, so the pool deposits. And at this point, the pool has 2,000 units. So let's say user deposits 2. And they got 4. So that first step executed fine. Now, so now we're looking at available, same as here. So if the available currency for the pool is greater than 0, then user 1 should be making a choice in depositing. So we'll say, so user 1 deposits 1 again. And sorry, now it's working.
Now it's working. But
so we'll do user 1 again. Sorry, we'll just do 1, 1, and they should get 4 each, 2 each. And this time, let's do a 1,000. I think I might have put a number in here instead of. I think I might have moved to a slot instead of choosing how much to pay. I think that's what was wrong before. I'm not 100% sure. We'll have to go back in the video and check. Okay, so this time user 0 goes 1,000. I'm going to buy it all.
Oh yeah, buying the whole pool.
Yeah. And they deposit it. And at that point, we're done. Perfect. So that's
and it doesn't even ask for user 2. Now go back though and put restart it. No, retest in the deposit 500 for the first one. And then 600 for the second one.
Yeah. This is where we're going to have some issues. Because basically, well, let's have a look at what happens. So pool deposits, 500. So far, so good. And it pays out immediately, which is maybe not what we want, but and now we go 600. And that they deposit. Contract paid 1,000. Oh, that's a ripoff.
Yeah, it ran the contract still, but it only paid what was left in the pool.
Yeah.
It's interesting though that it still performed the contract with
Yeah.
so that's like one of those things to definitely figure out the.
Okay, so let's see if we can in this case, I think let's just split up the so we got this, and then we've got this again.
So no matter right now what the second depositor comes in with over budget, he's only going to get what remains in the pool,
which is not good. So let's try and fix it. So I think we need to I think we basically, like, unfortunately Marlowe doesn't give you the option of like going back. Well, there's two issues really that we're gonna, like, there's two ways that I would kind of try and do. One is that it would be great if here this choice amount could just be dynamic, but you see it can't be. It's something you put in, you can't plug in another puzzle piece, which means on the Haskell side the types are like that too. So yeah, it's not going to work like that, because that's one option. We could just have the last user just can only input what's left, but that's not really an option for us. So I think the other thing, which is a little bit terrible, because the user kind of has to know how much is left, and I mean they've got full observability on the contract, so maybe that's okay. But I think in once this payout, like once this deposit has happened, I think we need to say if the deposit was too big, then end the contract before. Oh, but we want to end the contract before anyone's paid. No, I'll tell you what.
I was trying to think how to use a if observation on the same way you're using it now, kind of. I was trying to think of how you could use it on the deposit, like the checking the deposit amount somehow. So
okay, yeah. So we've taken this, we've had a little bit of a we've skipped this intermediate step. We're depositing directly into the pool. So we've got the option of refunding it if it's too much, like basically just ignoring, like if it's too much, we can just refund it. Or alternatively, we could have the user deposit into their own account, and then do something along the lines of, if the balance in their own account is greater than what's left, then we don't even pay it to the pool. So in that case, like, it's not ideal because they're trying to put in money and they can't, but at least they're not overpaying. So basically the idea is to reject overpayments.
That makes sense.
So let's do that. We're going to have to split it up a bit. I will just, because this bit is the same, I'll just delete this whole thing because I'll have to duplicate the next one. So basically, oh, no, it's even easier than that. Great. Okay. We know how much they're going to deposit. So like right here, we can just stop them. Basically, if they choose too much, we'll just not take the deposit at all.
Okay.
Yeah.
Let's see
so
that.
I think
I'm not sure how you're going to do it, but I get what you're saying.
So if sorry, if observation, so we'll say value is greater than or equal to, I guess.
Can you zoom back in a little bit too? Just
Yeah,
maybe
yeah.
a click.
Yeah.
Much better, thank you.
Yeah,
Much
sorry
more
about
readable.
that. It's kind of a zoom out when you want to see the bigger picture. Okay, so we want to look at that choice. If the choice is
Greater, if you duplicate that available currency up there, I think that's what you want to plug in there on your the starting of that if.
So we've got because this is ADA that they deposited and this is WTIM, so we've got to do a multiplication. So I guess like, I guess we'll just do a times now. We don't have to do that division thing anymore. So that's that's 2. And I'll also duplicate this thing and just use the same thing in this part because there's no point in complicating things. We know we can use a different thing if we have more complex logic. This is fine for now too. Okay, so if that is greater than or equal to the available currency,
Yep, that makes sense.
then we wait for them to deposit, right? Otherwise, now here's how, this is cool. So kind of cool.
It's pretty cool.
The problem is as soon as you've got an if, then like the Haskell side of this can explode because there's 2 branches for every user. So I guess like now we've got to decide what to do with this user. Like we could simply just like because I'm tempted to just skip them. I'm tempted to just, yeah, I'm still here, sorry. I'm tempted to just skip the user.
Losing you.
Oh, just 1 second. Are we back?
Cutting out really bad. Okay, there you go.
Okay, cool. Sorry about that.
Yep, no worries.
Like I said, battling my internet service provider, and when my phone rings, I lose connectivity. Super annoying. Okay, so where were we? Yeah, so we have this. We have to decide what to do if in the case where we've gone over where the deposit has gone over the line. So we have the choice of like doing nothing, just skipping that user, in the sense of, well, you've got to be careful that you don't go over. So yeah, you went over, sorry. Or we could try and prompt them again, right? So we could try and kind of do this whole choice again for that same user, which is like kind of re-prompting them. But there's no way of truly looping in this, right? So you've got to decide which depth to go to because it's all going to be finite. So I think in the sense of like just for the sake of keeping the contract smaller, because I think in Marlowe that's always a constant concern. I think we're going to just skip that user. So meaning,
yeah, I think it for now that makes sense.
yeah. So I will just quickly put in close for both sides. And yeah, let's have a go at that.
You got to put it back in the main brackets.
Yeah. Oh, hang on. Oh, good. Yeah. It's not lost. You just got to go do Command Z. Like if you accidentally do this when it's disconnected, you'll find it disappear. And it's super scary. But you can Command or Control Z, and that'll bring it back. It's a pro tip because I've had this happen a couple of times.
Good to know when you come back and all your work's gone.
Yeah. So let's save. We got to keep saving. But yeah. So basically you can't try simulate it if it's disconnected, but if you try view it as Marlowe, and then you go back to Blockly, it'll be gone. But yeah, the undo shortcut does work, thankfully.
That's good to know.
Otherwise this would have been ruined. Yeah, so now we're good. Send to simulator. Okay, so we'll start the simulation. So yeah, user 0. With user 0, we're actually okay now because they literally can't do more than, so their limit is, I guess we have to
we'll put it in like 1001. See what happens.
Yeah, but the limit is yeah.
So would they get
it on user 2? So that's all right. We'll reconnect user 2. So that's 1000 now, which actually works because it's not over the thing. So let's zoom out a little bit just for, so it's this thing here and we want to duplicate it. And now there's a few, user 1. User 1. User 1. I think that's it. So we'll make this slot 40, this slot 60. And I think that's all we have to do. So we will once it's been paid, then we continue with the next user. But sorry, let me just also duplicate it and I'll show you why. So we want to continue as here, but in the case of this, if this observation was for some reason false, we probably want to continue with the next user too.
Yeah.
So that's basically saying like, well, you know, you had your shot. No, sorry, let me just undo a couple of things because I think I've done it wrong. So that's, yeah. Let me just delete this one. So we've got user 1, user 1, user 1. That's user 1 as well. Okay, and now we want to duplicate this one. No, gotta be careful not to accidentally put it in the bin. Cool. So 1 there, and on the else part, and just to make this testable with user 1, I'm going to change this slightly and just increase the choice that they can make to 1001 here. again, it's better not to give them an invalid choice, but just to actually check that we've
test some things out. Don't forget to save as well.
Yeah. So we'll simulate that and we'll start the simulation. So, okay. Basically, so deposit. So, okay. So in the case now, if user 0 goes over, $1,001, then nothing should happen with user 0. They should not get our choice to deposit. Unfortunately, there's no message. Like, I'd love it if you could send the user a message, but I thought we fixed this. Let me just see. Users, we did it for user 1. Okay, there we go. Okay, so 1001. That's not good.
We'll push it. See, you haven't pushed it yet. What happens next?
No, it overpaid because they've given. Yeah. Okay, let's have a look at what. So, if the observation is greater than 0, then they choose between 1 and 1001, and then if the choice of deposit times 2 is we made a mistake.
You might have to zoom in too.
Oh, yep. So that's what we have right now. So if the amount is greater than or equal to, so we're trying to execute this thing. If it's greater than or equal to, it should be less. Like, no. Yeah. If it's less than or equal to, then we should execute.
Yep, that makes sense.
If it's greater than or equal to, then, so it's just a matter of changing these things.
And then we would need to replace that green value for the other ones too, or is that only in this case?
This one's okay because this is checking is the pool greater than 0, which is fine, but we will have to replace this one here. The use and it'll be in 2 places because we've duplicated it. So we'll just duplicate that one. And we'll also, the 0 is fine. Sorry, so we'll
you need to change the role.
Is a 1, yeah. Yeah, unfortunately, when you're building anything at all complicated and in Blockly, it gets very complicated very quickly.
I think you deleted the wrong one. Go scroll down. I think you still needed that one. You just
let me just undo. Yeah,
you're right.
Go. Yeah, thank you. It's a team effort.
They gotta keep track of all this blocks.
Yeah. Okay. So we have that one. We have that one. They're all less than or equal to. And in the second case, we close, obviously. And then here we've got less than or equal to. Okay, so that looks promising. So let's just do the happy path now first, because so let's just do 1 and 5.
Yeah, make it work.
Yeah. So they chose 1 and they deposit 1. Great. And they got 2 WTIM and then user. Okay. There's a bug. It should be user 1 now. So that's user 0 is fine, and then we got then when. Sorry, I'll just split it up because I find this splitting up to be.
If you go down to the third win block is when you right there. Right? Yep.
Yep, that one. No, oh yeah, there's a choice. Yeah, cool. Okay. And there was another when block because this was actually sorry. I'll just take this whole thing. Not just the thing containing it. And then there was this one here. So I'll delete both of them. Yeah, so there was another when above this, right? Yeah, cool. Okay, we're good.
Well, there's your whoops. There, I was gonna say that was your why it was doing it. That was supposed to say user 1, but it still says user 0.
Yeah, here.
Yeah, there you go.
Yeah, cool. So we'll fix it in one place and then duplicate it again. That's why I deleted it, because I didn't want to be fixing it in two things. So one here and one here. Okay, cool.
Now we should be rocking.
Let's save it. Oh, and we've got to also connect it here. Yeah, so I found the splitting and then rejoining to be easier for debugging than, it's a little bit of work, but it's like basically easier for debugging than just staring at a big blob, at least for me. Okay, so 2000 deposit 1 by user 0, choosing to deposit 1, and then they deposit. And they got 2. And then user 1 chose to deposit 5. Then they actually deposit 5. And they got paid 10, and we're done. Cool. So that's the happy path now working. Now let's have user 1 deposit 1,001 this time. Sorry, when I say user 1, I mean user 0.
User 0, yeah, I know.
Yeah. And now we've got user 1. Now you notice nothing else happened. So because they chose too much, they lost. A
deposit didn't happen, but neither did a payout.
Yeah. So like that's not the friendliest kind of like from normal software, obviously that wouldn't be acceptable. But these smart contracts have limits, in the sense that they're guaranteed to execute exactly like this. And as such, you can't necessarily have friendly error messages and things like that. But yeah, because it'd be nice to kind of reprompt and have them enter something or opt out.
Really, I think the only way you can address that right now would just to be like on your off-chain code of your like user interface. You could be like somehow blocking them from
yeah, that's right. On your if you got a user interface to this, you could add extra validation and stop them, but the contract itself just needs to handle this case, and I think it's good that we are handling this case. Anyway, so user 1 now has the ability to deposit, and they can do 5, or I said 15, sorry, and they deposit 15. So yeah, the pool gets back 1970. And we got 15 and we got 30.
Nice.
That's cool. Now, there's one more thing we're going to do on this. And I'm sort of conscious of the lesson length. So I think at this point, we're going to stay in the Blockly space and not do this generalization. We'll leave that for a future lesson.
Sounds good.
Because the next 2 lessons are basically going to be running this on the Alonzo testnet, and generalizing it to more than 2 users.
Allowing multiple parties to come in.
Yeah, so that's fine. That generalization of multiple parties is where we go into the Haskell world and kind of define a maximum number of parties. And yeah, we'll do that when, like, depending on how the Alonzo testnet thing goes, we'll decide what's next. So the next lesson may be that. Or if we get testnet, then we should get something running on the testnet first and then generalize this. But that's the future of this. Anyway, one thing that I'll go on.
I was gonna say, on this contract, how, just a little last little tweak on the end of it. What about adding an if observation? So deposit user number 1, depositor number 2.
Yeah.
After they deposit, the if observation would be if there's still WTIM tokens in the pool, the contract waits a long amount of slot numbers, right? Into giving time for other people's to enter. And then if the slot number is reached, then the contract comes to end. So like right now, we've got it set where after the second depositor, it just automatically ends. What about adding that it's if operation, so that way, like, it doesn't just end right after the second deposit, it waits, and then after a slot number closes.
Yeah. Okay. So yeah, it's
you understand what I'm saying? Like, so right now, just that instead of the close on the depositor number 2, could we just like, we don't have to work it all the way out, but it would be like an if observation based on the balance of the pool. And we don't have to, it's just the kind of building on when you're talking about multiple parties involved. So that was just, I was like thinking out the how you wait for those multiple parties is based on the amount still left in the pool.
Yeah, absolutely. So one thing I'm a little bit unclear about with these Marlowe contracts is how the entering and how the entering of the contracts even happens. Like, does everybody have to enter at the beginning, or can they enter, you know, can they kind of keep entering while the contract is already executing? So I'm just gonna, I mean, if it's the former, then there's nothing we can do. So let's focus on the latter, what we would do. So I think, like, really what we are, let's do it after, like, just to keep our number of participants at 2, because any more than 2 we want to. So really what we're talking about is like on here, like, if basically wait for, don't just close here if this, you mean if this person doesn't come in, or because
well, no, I'm just saying, like, so the contract right now is ending based on a deposit, and I'm saying that it would not be ending based on the deposit, it'd be ending based on the pool. So once the pool is either depleted or a slot number has been reached, you know, like a time period, then the contract ends, not based on a deposit event.
Yeah, I see. So okay, I see. So what we,
and again, if I also appreciate, you know, the time, the lesson. So if this is something, you know,
let's
cover
just
another lesson.
Let's just plan it out. I think we've got a few minutes to plan it out, and then if it's simple enough, we can try do it, and if it's a little bit more complex, then we can postpone it for the next one.
Awesome.
So what we really want to do is we want to stop when there's no more money to give out. And that's actually already handled by this observation here. So if there's no more currency to give out, no more WTIM tokens to give out, then we're good. So the next thing is, now we want to say, well, what if, like, we want to time out we want to end the contract immediately up to a deposit, right? Sorry, we want to, if the number of slots that we have allocated for this contract has passed, then we want to end, rather than wait for another observation. And I think we already basically have that, right? So what this is saying is we've got an if. So if the available currency is greater than 0, then we keep going. And then somehow we've duplicated up on this if, but I guess it doesn't matter.
Well, one of the ifs is for the, oh no, you're right. There is a double.
Yeah, I can zoom in a little bit. All right, I guess I can just get rid of it. See what okay, so here then, if we have no money left, then we are in this close and we're done, right? The contract is closed and all of the balances are paid out. Now, what happens in the case that this user doesn't come by slot 60? And really what'll happen is, again, so if this user comes, we're waiting for this up to slot 60. When we get to slot 60, the contract is closed. So at that point, this user and all of the following users, which would come here, can no longer join.
Mm-hmm.
So I think this basically satisfies our requirement. Does it not?
Let's see. Yeah, but why is it ending though after the? So what I'm saying is that after we in simulation do the user one, which is the second deposit.
Yeah.
The contract is just ending. What I'm saying is in simulator, the next thing that should happen is like it should, be waiting for another user or another, a certain amount of slots based on the available balance. So it's almost like there's a
okay. So do you mean that if there is available balance, then we want to wait for more users for longer? Yeah.
Yes, gotcha.
Yeah.
Yep. So it's instead of closing, it's like another if, or I'm not really sure how you do it.
Yeah. So I think so let's look at the user one case. The reason I want to look at the user one case is because then we can kind of go, well, let's look at the user 0 case, and then like user 1 is the one we're waiting for.
That makes sense. Yeah.
Because I think we so again, we can say after slots. So do we want to, just to understand the requirement here, I think we actually want to, like, how long do we have a fixed number of slots for this crowdfunding contract? I think we do, right? Like, ultimately, we only allow users to come in and deposit up to a certain number, say, I don't know, 600 slots or 6,000 slots, whatever. So maybe, because at the moment, right, we've got, because at the moment, I've just given everyone a constant number of slots to, let's go in the simulator. I think it'll be a little bit simpler. Are we all connected? I think so. So we're at slot 0. Okay. And here the pool has 10 slots to make their initial deposit. I think that's fair because, they have to.
They're going to be starting the contract.
So let's go to slot 11 instead of making a deposit. Contract is over, nothing happened, right? Which I think is correct behavior, because that means like just, the main organizer didn't come to the party. Now,
yeah,
the pool deposits. Now we've got user 0. And remember, by convention here, at least the way I'm thinking about it is user 0 isn't like, user 0 is not Tin or Boone or, it's not a specific person yet. It's just user 0 is the first person who comes in. Right. So we're basically at this point waiting for the next person until slot 20. Right. And if slot 20 doesn't, like if we go to slot 21, then, it's all over. Now, I think that's probably not what we wanted, right? Because we wanted to wait till the end of the contract for anybody to come in.
Yeah. So like, for example, if you made like this 7-day crowdfunding campaign or something, you would want it to wait 7 days for the very first depositor to come in.
Yeah. Completely agree. Now that we've kind of spelled it out, I agree. So let's look at all of those whens, and we'll just make them all when. Sorry, let's just do what we've been doing. So I think the pool is okay. That's the one that's like easy. Let me just, so the user makes a choice and then we pay them, and then we do the available currency thing. And same here. Okay, something like that. So I think when we wait for that deposit and when we wait for that choice, actually, like, let's just make all of these numbers the same, say 600.
Okay.
6,000, whatever. Yeah. So instead of having increasing kind of deadlines, let's just have one deadline for the whole contract. And during that time, anyone can come. So we've done that. We'll do the same here. Oops. I'll delete this one and duplicate it again. So we've got, once the user has deposited, and the case is closed, it's there. Because I think this is an excellent question, and it's something I've always been giving people incremental actions to do something, but actually that's not correct, because we want to give, especially for the deposit part, we want to give the next user as much time as they want until the end of the contract. Yeah. So I think this is better. Now let's just simulate it and see what.
Put back in the main plug.
Yeah. Okay, so we start on 0. And now the pool just participates. And now, user 0, which is just the first user to make this choice. Now, okay, I can see a small issue. So let's say, they choose 1. And now they've got 1. Now they've got 1 slot, like, now basically the problem we've got now is this user has made a choice, and now they can ruin the whole contract by timing it out, like by not depositing. But anyway, if we ignore that, we'll try and fix it. But if we ignore it, then it's user one's turn. And again, they've got until the end. So I think that's probably with these timed crowdfunding contracts, rather than doing incremental periods of time, I think we want to do one like that.
Well, yeah, but the other thing I'm seeing that could be an issue would be that every time a deposit made, does that mean there's 6,000 more slots after that, or is it the original 6,000 slots?
No, it's the original. It's the original. So we've tested this earlier, and those slots are since the beginning of the contract, not from now.
Gotcha. Okay, I just making sure I remember that right.
Now, one thing I'm interested in is there any way of us to get the slot number? I think like the current slot number observation. No, because what would be really nice, right, is if this choice had a big timeout, so you've got as much time as you want to make a choice, but once you've made that choice, you have only a certain amount of time to make that deposit. That's just to prevent you from basically just making a choice and then holding up the contract till the end by not.
Yeah, that makes sense. That as soon as you make the choice to make a deposit, that you have 60 seconds or something to enter, because it really shouldn't be a long. I mean, people are going to be doing this all in one setting,
Yeah. So really, we want to, at this case, after slot parameter. Wonder what a slot parameter is.
Maybe that's based on the actual chain. So you could maybe call out a slot number in, that's coming in the future. So you could set your contract based on actual slot numbers on the chain.
Yeah. So let's do a new project and see quickly if we can do that. Basically try to work out what it means. So when actions deposit by we'll make this one super easy. Token. Because I really just want to see what that parameter thing does. Okay, and we'll make it after slot parameter 10. Let's see how that looks. Send to simulator. Oh, that's just that's just the parameter, literally. So that could be called timeout or something like that. So that means we've got a parameter for, timeout.
Oh, I gotcha.
Which is cool, a naming, but not what we want. Yeah, and then that's now. Okay. So yeah, that's one question, I guess, that we've got a little bit unresolved. Like, how do we stop the user from hijacking the contract by choosing at the beginning and then never depositing. And I think just I don't have an immediate answer, so I'll have to get back to you.
No, I think it'd be good for us to, now that we've kind of brainstormed around it and played around in Blockly, you know, maybe call it good for the lesson today, and then we can leave off, we continue from where we left off today with what we discover. And
the other thing we want to do is move it to Haskell. So there's some of these decisions can be done off chain, in the sense of, hey, how much are you going to deposit, and when are you going to deposit it? And then we can, from the Haskell side, because that's run off chain, we can kind of set up those limits like that. Because it would be really nice if, like, I really like that we managed to keep that choice on chain, but now we've got that denial of service attack potentially. Which, I mean, we can just rerun the contract until people stop doing that, but it's not ideal, and it costs us data. So we'll think about that in the next lesson. But I think I hope this covered kind of, I guess, the kind of details we have to think about to make real contracts. Like, it wasn't particularly technical; it was all in Blockly, but at the same time, I hope that it was valuable in terms of.
No, I really like working in Blockly, and again, you know, it's just like you mentioned, it's finding the technical limitations and you know, learning how you can work around them to accomplish what you're trying to get done.
Yeah. Cool. So I'll stop recording at this stage.
Thank you.
No worries.